Well, in this lesson, we come to the D in solid. Now, unfortunately, this is one of the most difficult to understand. So this stands for dependency inversion. Note that I said inversion and not injection. A lot of people instinctively come to the D and they think, oh, that stands for dependency injection, so I should pass arguments through the constructor. Now, dependency injection is important and it does allow for dependency inversion, but the two are not equal. So if that's true, then what does dependency inversion actually refer to? Well, it states high-level modules should not depend upon low-level modules. Instead, they should depend upon abstractions. But here's the thing, the low-level module too should depend upon abstractions. But once again, we hear a definition like that and it just basically flies right over our head. What exactly am I supposed to do with that? What does that even mean? High-level module and low-level module, what does all that mean? Well, here's the basic end result of successfully leveraging dependency inversion. It allows us to decouple our code. And really, that's what all of this comes down to. It all comes back to how can we design better applications. So when we think about bad design, we think about code that is hard to change. If you've ever had some kind of class or component where you were hesitant to touch that code because it was sort of like a black box and everything's working right now, but you don't really want to touch it because you might break the whole thing. Well, clearly that's badly designed code. Think of it like spaghetti. If you were to reach your hand into a bowl of spaghetti and you just wanted to grab one specific noodle, that'd be a little difficult, right? Because it's all tangled, it's all coupled together. And at least in programming terms, that's a dead ringer for bad design. But luckily, these various design principles, remember, they're all connected, they all work together to help us design better applications. Now, before we move on though, it's important to first discuss what I mean by high-level versus low-level code. So when I say high-level, I want you to think of code that isn't concerned with the specific details. However, low-level code, that's going to be the opposite. Low-level code is intimate with the specifics and the details. So what this principle states is that your higher-level code should never have to depend upon that low-level code. Or, in other words, one class should never be forced to depend upon a specific implementation. Instead, it should depend upon a contract or an abstraction or an interface. Now, how about an example? And this is one you'll hear a lot. It really does help. So imagine that you have something like a lamp or a TV or a stereo. Now, we need some way to provide power to those devices, right? Well, that's what we have a plug for. But imagine that we didn't. Would we instead have to connect the wiring from your house up to the wiring of the device? Well, that wouldn't seem right. Instead, we have outlets, and think of an outlet as an interface. Or, in other words, these electronic devices that we have, they don't need to understand specifically how they receive power. They simply need to rely on the fact that there is some interface that they can hook into that will give them what they need. Hopefully that makes sense, but let's take it one step further. Your house specifically provides the outlet, and remember, think of that as the interface. So from that point of view, your house owns the interface, or the house owns the abstraction. So it says anything that wants to receive power absolutely must conform to this interface that I've provided. So notice that the device, the TV, the lamp, the Nintendo, they do not own that interface. They conform to the interface. So this backs up that idea that high-level code depends upon an abstraction, but low-level code too depends upon an abstraction. But the interesting thing, like I noted, is when you start asking which part owns this abstraction. That's where things get really fun. Now, let's move on to review the obligatory code example, and we'll use one that's very popular. So imagine that we have our class password reminder, something like this. Now, we might have within our constructor some kind of database connection. So we could just call that DB connection. However, I'm going to type into that, and we'll say that's going to be our MySQL connection. Now, this is bad in a number of ways, but just stick with me here. Now, what I want you to do is pause this video and really think about what the downsides are to this approach. When you're done, press play again. Okay, so let's think about this. First, we come to the question, Why should password reminder have any interest whatsoever in what our database connection is? Fine, we're using MySQL, but why does password reminder care about that? Well, if you directly associated dependency inversion with dependency injection, you might think, wait a minute, this is fine, we're conforming to it. We are injecting our connection into password reminder, we're following all the steps, everything's good to go. However, like I said at the beginning of the video, those two are not the same. This, in fact, is breaking the dependency inversion principle. Now, how come? Well, once again, high-level modules, which is the password reminder class in this case, should not depend upon low-level modules, which is the MySQL connection. Now, what are we supposed to do instead? Well, high-level modules depend upon abstractions, not concrete implementations. And if that sounds confusing, don't forget to bring all of this back to the idea of knowledge. Does password reminder need to have knowledge about how you connect to your database? No, it just needs to know that there is some database connection that it can work with. So instead, we would code to an interface. Once again, we refer to that phrase. I've told you in every single lesson in this series that code to an interface is laced throughout all of these principles. So if we set up our interface, maybe we'd have an interface called connection interface, and all it provides, at least in this example, is something that says connect. Now, if we follow this principle, password reminder should depend upon an abstraction. Now let's go to that second part of the rule. Low-level modules, too, should depend upon abstractions. So now, if we create our first implementation, we'll say MySQL or DB, it doesn't matter. Let's call it DB connection implements connection interface. Now, once again, we add the method subs, we do whatever is necessary to connect to our MySQL database, and now we are in conformance. The low-level module depends upon the abstraction, and the high-level module depends upon the abstraction. That's how that works. So the main thing I was trying to convey here is that dependency injection does not equal dependency inversion. However, dependency injection gives us a methodology, so to speak, to conform to that principle. I know that's confusing, but try to spin that around your mind. But nonetheless, dependency injection is incredibly important. It allows us to conform to this principle, like I said. It makes testability much easier. There are a number of reasons to use it. Now, there's just one more thing I want to talk to you about. Remember earlier in the video when I started talking about ownership of abstractions? This can be confusing, but try to think about it. Who owns connection interface? Does DB connection own it, so to speak? Or does password reminder own it? Now, what I mean by that is, yes, password reminder depends upon connection interface. However, what if we wanted to update DB connection? Maybe we need to change the way it works. Well, it's possible that changing DB connection would cascade to a change in connection interface, and then once again, that can cascade down to any class that depends upon it. And so as a result, this is what brings us to terms like IOC, inversion of control, or who exactly is in control here. Going back to that electrical devices and the outlet example, who's in control there? Does the device dictate the interface? Meaning, does the Nintendo or the TV dictate how it fetches power? No, it's the other way. No matter what the inner workings are of those devices, at the end of the day, they absolutely must conform to the interface that is provided to them. So, in effect, they do not own that abstraction. Now, I know that probably comes across as confusing. It took me a really long time to fully understand that in terms of how I code my applications. But it's nonetheless something that you should really study on your own. Read everything you can find on this subject. It's a pretty complex idea that could have a drastic effect on how you design your applications. Ultimately, though, the core idea behind this principle is that your high-level code, in this case password reminder, should never ever depend upon the low-level code. It depends upon an abstraction, and now the low-level code depends upon that same abstraction as well. This allows for the complete decoupling of our code while still providing some way for the two modules to interface.